because every day we are facing a lot of energy problems and also the power cut. So maybe the today lecture, whatever Dr. Assistant Executive Engineer in TNEAP is going to deliver the good lectures and also solve problems. And also that is the sustainable things, energy storage in future. So that is the focus. So maybe the entire thing will be fixed in our. So in this lecture, on behalf of Institute of Engineers India, I welcome you all the participants for attending this. I think our Honorary Secretary Bala sir going to Bala.
Yes, sir. Balaguru sir would be introducing
Okay, our Joint Secretary Balaguru sir, please introduce our
guest
of this program, Knowledge Event.
Okay. Yeah, good evening, one and all. First of all, I have to thank Professor Dr. Ilango, the chairman of IEI TNSC, Dr. J. Balaburgan, the Honorary Secretary of IEI. And indeed, it's my pleasure and honor to be here. The wonderful topic today, the grid forming inverter, energy storage, and the next phase of renewable energy integration in India. So, Mr. Nallasivan, actually, he is my colleague and a very good friend of mine. So we associated for nearly 25 years of in this relationship, very good relationship. And Nallasivan is a seasonal power system engineer with over 2 decades of experience in the power sector, spanning power system studies, transmission and distribution operation, renewable energy integration, smart metering projects, and energy implementation. Currently serving in the power system IT domain in Tangetco, Chennai, he is leading open access automated meter reading initiatives that support digital transformation and renewable energy integration. And the highlights about this Mr. Nallasivan, 20 plus years of experience in various, that is in power sector, generation, transmission, distribution, and renewable energy. Leading open access AMR initiatives in Tangetco. He is a certified TOT on rooftop solar, entrepreneur skilled council for green jobs. He contributed extensively to the power system studies and grid planning in Tamil Nadu. He served on deputation to TEDA, Tamil Nadu Energy Development Agency, as a deputy senior manager, solar division. He worked as an assistant executive engineer in Ennur Thermal Power Station, and he associated with the many professional bodies, member of IEEE, IEI, ISTE, SPEI. And he many publications on to load forecasting using ANN, hydrothermal scheduling, and hybrid approach to reactive power planning, unit commitment approach to TNEB, a novel approach to hydrothermal scheduling using hybrid technique, and economic dispatch of wind turbines. And his vision to contribute towards the building intelligent, resilient, and sustainable power systems that enable large-scale renewable energy integration while ensuring grid reliability, flexibility, and operational excellence. With that, with you all, I welcome you, Mr. Nallasivan, welcome you, sir. Thank you.
Okay. Thank you, my friend, dear Balaguru.
Yeah.
Good evening to one and all. Is my voice audible?
Perfect, sir. Please proceed.
Okay. Good evening, one and all. Respected Professor Dr. Ilango, respected Professor Rajamani sir, my colleagues, Sri Raja Balaguru, and my friend Balamurugan, and all other engineering faculty students who are into this webinar. Good evening. I wish to start the session. So today's topic that has been assigned is beyond capacity addition, grid forming inverters, energy storage, which is the next phase of renewable energy integration in India. So this would be the outline of our presentation. Firstly, we will be going through about the green energy transition in India. Secondly, would be on the renewable energy statistics across India and in Tamil Nadu. Then we move on to the grid changing era from the synchronous machine era to the inverter based IBR era. And moving on, we'll be going to see what is about grid forming inverter and how does this differ from the grid following inverter. What are its special features and how does it work, where it has to be deployed, is it the need of the hour? And then comes India's energy storage mission. And lastly, we will be seeing on firm and dispatchable renewable energy. So this would be the brief outline of the presentation. And now let's move into the actual presentation. This is about driving India's green energy transition. Most of you, we all would have known about this. You all know about the Prime Minister of India's ambitious vision in this. The government of India initially target was about 20 gigawatt of solar under the earlier Jawaharlal Nehru National Solar Mission. And then in the COP 2026, the target has been revised. So if you could see the presentation, and most of you would be knowing this, 500 gigawatt of non-fuel fossil fuel-based energy by the year 2030, out of which almost 280 gigawatt would be from solar. The Panchamrit framework, it also stands by that India would consume almost 50% of energy by 2030 from the renewable energy. And there is a carbon emission reduction mission, which says that reduction of almost 1 billion ton of CO2 emission reduction by the year 2030. And there is also a carbon intensity reduction of almost 45% by 2030. And the nation, going by this framework, has to achieve a net zero emission by the year 2070. So this is about the green energy transition and about the various statistics. And now, how are we going to achieve this 500 gigawatt and what would be the projected capacity breakdown? So if you could see, the ambitious solar target is almost 280 gigawatt, and as of May 2000.
Hello.
So as of May 2026, India has commissioned almost 158 gigawatt of solar energy. So at present, so if you could see, this would be our installed capacity across the country as on 31st of May 2026. Coal is almost like 223 gigawatt. Hydro is 51 gigawatt. Wind is 56 gigawatt. Solar has crossed a milestone of 157 gigawatt. Biomass, waste to energy. So entirely, all these things contribute. Now, if you take the renewable energy contribution from under various state sectors. So the various state sectors would be like Gujarat leads in the state ranking. It has almost 50 gigawatt. Rajasthan follows by 48.23 gigawatt. And Maharashtra leads third with a total renewable installed capacity of 32.92 gigawatt. Tamil Nadu comes fourth with an installed capacity of 29.45 gigawatt. Karnataka is placed fifth, and sixth comes Andhra Pradesh. Now, if you see wind, Tamil Nadu was the leading wind installed states until 2 years ago. Now, Gujarat has overtaken. So, Gujarat is having an installed capacity of almost now 15.85 gigawatt. Tamil Nadu has fallen behind Gujarat. It is around 12.16 gigawatt. Karnataka is 8.86, Maharashtra and Rajasthan. In terms of solar, if you see the state of Rajasthan leads, it is much ahead of all the other states with an installed capacity of almost 42 gigawatt. Gujarat comes second, Maharashtra is third, and Tamil Nadu ranks fourth, and fifth comes Karnataka. So if you see the highlights of Tamil Nadu's contribution across the nation, we are almost fourth in the total renewable energy capacity. That is, we are close to almost now 30 gigawatt. second in terms of wind power capacity, fourth in terms of solar power capacity addition. So this slide shows about the Tamil Nadu power demand and consumption growth for the almost a decade. If you could see, the total installed capacity of wind in the state is almost 11.6 gigawatt, out of which the wind electric generators that is connected to the state transmission utility is 9.4 gigawatt. Central transmission utility is to the central transmission network, that is almost like 2 gigawatt. Solar, the total installed capacity is close to 14 gigawatt, out of which that is connected with the state network is 12.1 gigawatt. We have an excellent solar rooftop across industries and domestic consumers that goes to almost 1.6 gigawatt. And a very few number of 150 megawatt is only connected in solar sector across the central transmission utility. Now, if you could see the slide, the consumption from the year 2016, it is like 15,343 megawatt in terms of peak demand. So this year it has crossed 21,307. So if you could see, that is almost um, some 15 to 17% demand in terms of peak. And if you could see the daily maximum consumption across the 10 years that has been tabulated in the graph, in the year 2016, the day per day consumption in million units was the highest was 345 million units. Whereas if you could see in 2026, now the record that was in April, it has almost gone to 471.4576 million units. So this, in terms of daily consumption, is almost like 37% increase over the decade. So, what are the factors driving behind this power demand and power consumption? So, first and foremost is the rising temperature. So, it's all in the media, and the forecasters and power system planners are having they're burning their light lamps on the El Nino and other effects of the nature, and then the increasing air conditioning loads, then urbanization and rapid industrialized growth across the state of Tamil Nadu, and the other growth drivers, or perhaps the rising standards of the people, and also people are adapting to the electric vehicles and electrification of the fleets. So these are the contributions, like where now the Tamil Nadu power demand and consumption growth. And now we move on to a small statistics that has been taken from the T and load dispatch centers. So if you go by this graph, you can see the day-wise demand of wind and solar that renewable energy has contributed in April. So the all-time consumption high has already been highlighted in the previous slide. That is on 29th of April, our maximum demand has sustained peak has grown almost like 21,307 megawatt on 29th of April 2026. And the consumption per day maximum consumption is almost like 471 million units. So you could clearly see the graph. It has been plotted for the month of April. So each day, this 15 minutes interval has been given. So what are the maximum contribution both from wind and solar? So you all know that during the month of April, the wind that is marked in blue. So it is the wind season has begun right now, a couple of weeks. So there is not much contribution from the wind, but you could see the solar is almost like contributing roughly about two-third or nearly one-third during the daytime hours. On an average, if you see, it is not less than 40 to 45 million units. Only on few days, it is like 35 million units, and the other day you can see it as 42.9 million units. So this is just the combination. So we'll move on to the next phase, like as per the agenda, like how the grid is changing from the synchronous machines to grid forming resources. Now, if you would have gone by the statistics all across our country, there has been a rapid transition of renewables. You could see like 156 gigawatt across the nation, and almost like 13 gigawatt of solar, and 12 gigawatt of nearly wind. So if you see how this transition takes place from synchronous machines to grid farming resources. So if you could see earlier, the grid was a conventional grid with much less penetration of the renewable energy resources. So if you could see by the year around 2000, we had only few thermal stations and hydro power stations. So the characteristics of such grid was the grid had high system inertia, the strong grid, we had the high short circuit strength. So the fault level currents were very high. We had centralized generation architecture, and we had frequency stability inherently provided by all these synchronous machines. So now across these 2 decades, there has been an energy transition, and now you can say it as a green energy transition. So there has been a rapid declinement in terms of power injection from the firm power, that is mainly from thermal stations, but more and more of power injected through your RE sources like wind and solar. So such characteristics of this grid over the past 2 decades, when there has been a rapidly increasing inverter-based generator resources, you could see um, there is an increasing generation variability would be there, as you would have seen in the slide that I had shown 2 slides earlier. So the level of inertia availability is lower, and this stays the focus for the need to have better forecasting and flexibility, and how uh, to face these grid stability challenges that are emerging. And now, how would our grid further evolve? So that is there in the right side, like it has been marked as a future renewable grid, where I would have a more of wind, solar. Your BESS stands for battery energy resources, plus the topic of discussion on grid farming resources. Now, how does this characteristics differ from the conventional and transition grid? So if you see, the key characteristics would be like whenever there is a low inertia power system, there is a dominant from the inverter generation mix. So it would have the artificial intelligence enabled forecasting and controlled methodologies, and then real-time ancillary service markets, which are evolving in the Indian context. And further to add on, the grid farming capability, which would be mandatory. So the grid codes are yet to evolve and um, to follow. So that would be mostly on virtual synchronous machines. So what would be the key message on the changing in grid from synchronous machines to grid farming resources? So the challenge is no longer adding renewable energy capacity. The challenge would be like maintaining stability in the grid, inertia in the grid, resilience, and flexibility. So let's move on. In this slide, we will be seeing like the traditional grid and the inverter dominant renewable era at present. So if you could see, uh, why is the short circuit ratio losing its grip in the modern power system? So the comparison is laid in this slide. So earlier, as mentioned in the previous slide, the conventional grid had more of inertia that is being supplied by the synchronous generator of the thermal power plants and also from the hydropower stations. Now, as we move on to highly dominated renewable energy, so there is a paradigm shift from the system level fault level, that the short circuit ratio, to the new paradigm where the system strength lies in voltage stiffness, inertia, and its grid farming capability. Now, why does this comparison has occurred? If you could see, the short circuit ratio that is equal to short circuit power by plant rated capacity. If the grid has a short circuit ratio of greater than 5, normally it is termed as a strong grid. So when it is the short circuit ratio is on an average 3 to 5, the grid is weak. If it is very less than 3, it is to be marked as a very weak grid. So where we have more and more of RE penetrations, especially in the down south of Tamil Nadu, like Kayathar, Tirunelveli regions, and also the penetration across the regions of Udumalpet and Palladam. If you take nation wise, you can see the regions across um, Rajasthan and also in wind parks areas of Maharashtra and Karnataka, where studies have been taken by the National Grid, who have also come up with a pilot study report on these things. So now, why the short circuit ratio has worked before is the grid was dominated by synchronous generators, as highlighted. So it had high fault current, which was closely linked to the strong voltage support. That those are all firm power, high inertia, better frequency stability, and a strong synchronizing torque. Now, the energy transition has changed the rules. So, what are the energy transition that has taken place is more and more penetration of RE resources. So, battery energy storage is literally to come up. So, it is coming up in pockets across the country, and then the high voltage DC systems and inverter based resources and the challenges that is being addressed. So, in the context of Tamil Nadu's perspective that has been highlighted is, so we need at the present rate, we need a more of local inertia to be generated, the voltage stiffness, and the grid forming capabilities. So, what is grid forming inverter actually? And from technology to ancillary services, the future of the grid farming inverters in India. So it is going to be the future in terms of technology to the ancillary services. Now the Indian power system is transitioning from a grid supported by rotating machines to one increasingly supported by power electronics. So all these solar injected power or through the inverters. So the grid farming inverter is nothing but an advanced power electronic converter that can create and regulate voltage and frequency like a conventional synchronous generator. So this is the actual meaning and term that we could find in the book and from the publications of the Grid India reports. I repeat, grid farming inverter is an advanced power electronic converter that can create and regulate voltage and frequency like a conventional synchronous generator. Now, these grid forming inverters will become the new source of system strength and inertia and stability. Now, the question arises, and most of you would be pondering upon. Now, how are these grid forming inverters different in terms of hardware? And where should the grid forming inverters be installed? When should I install these, or when are these grid forming inverters required, and how much grid forming inverter is required? So where would I actually implement it, either in Tamil Nadu or in India? And how come these solar inverters become the existing solar inverters become grid forming? And then how come the battery energy storage systems would become the preferred grid forming sources? And finally, the future market designs in India, like how I have highlighted from technology to ancillary services. So the challenge is no longer adding renewable energy capacity. The challenge is again maintaining stability, system strength, and reliability in an inverter dominant power system. Now we'll be going through the following 8 or 9 components, like how grid forming inverters are different in terms of hardware. I think that slide is okay. We can go through it. So how does this grid forming inverters are actually different from the conventional hardwares? So if you could see the present hardware, in order to make this becoming grid forming, unlike the grid following, only firmware changes are required. In terms of firmware alone is required. Now, if you could see where this grid forming be installed, it could go priority locations where we have a low, very low, and a very weak low short circuit locations, renewable pooling stations. Like as you are aware, most of the solar and wind developers develop the concept of 10-1 pooling substations. 10-1 means from the Electricity Act 10-1, where a private or individual generator, he can build, own, and operate and maintain. So this is what Electricity 10-1 Act says. And then remote renewable corridors. Those are located far away from the load dispatch centers, and then weak transmission pockets. Moving on. So when does this grid forming I needs? When should I use it? So during high solar period, if you see in the morning hours, like earlier or the midday from 11 to 12:30 or around 2 o'clock, and then when the wind period is very high, and when there is a backing of thermal stations to accommodate the renewable energy power, which is under the must run status. So as you all know, the green power is given a must-run status. So all the power generated from the green energy has to be absorbed without any curtailment. So operationally, the thermal stations would be ramped down to a minimum extent. And then whenever the system has a very low system inertia, and when there is a contingency analysis like n-1 or n-2 conditions, and if at all there is an islanding situation, and then how much of this grid farming I need. So it will again require the system strength, the inertia requirements, fault level support, the fault MVA, and the real time adequacy. So there has been one report from Grid India where they have taken a study with the northern grid because of few disturbances in the solar park in the western region across Rajasthan. So that report you can see in the Grid India website. And in terms of Tamil Nadu context, if at all this is required, it would be like the southern wind corridors and also high solar injection areas. And the future would be with the battery energy storage zones and also renewable energy rich pockets with reduced synchronous generation. So the question arises, do we have sufficient grid forming capability right now? Yes. Do we have sufficient grid forming capability? The answer I would say is yes, but it requires uh, a few pilot studies in the 10-1 polling substations. And how does the grid behave invariantly whenever there is a very high peak injection of the RE resources? So moving on. In the same context, why battery energy storage system is emerging as the preferred grid farming resource. So as you all know, solar, it generates only during the day hours, and in our TOD slot, it does a contribution to the morning peak from 6 to 10 a.m. Though it is not sufficient, there is a significant contribution across the Indian subcontinent. So even when the national peak touched around 271 gigawatt on 21st of May at around 3:30 p.m., there was a significant power contribution from the solar power. And when the wind, it is again dependent, infirm, and intermittent. But whereas when you take a battery energy storage system, it is a bidirectional power. We can charge either from the grid or from the excess power that has been developed, generated by the solar power. So the inverted duct curve is being studied across the nation, where the excess energy that is getting generated from the grid connected solar stations can be used for charging mechanisms. And then when there is a need for power, these energy that is stored in the battery systems can be injected into the grid during the peak period, evening peak period. For example, in Tamil Nadu, it can be injected from the evening peak hours, 6 p.m. to 10 p.m., based on the discharging cycle, that is light down. The second would be like there is a very fast response from this battery energy storage system. So it would have a stable DC resource. It can serve as the ancillary services. So the ancillary service market is set to take up into the full context in the Indian systems. The battery energy storage system, it can be used as a black start, and it can support the grid at any time. So that is why the battery energy storage system at utility scale is emerging as a preferred grid forming resource. Now, we have an Indian energy storage vision based on this. So out of the 500 gigawatt non-fossil fuel target by 2030, the BES requirement would be like 47 to 60 gigawatt. In terms of energy requirements, it would be like 200 to 250 gigawatt hour. And then pumped hydro storage, which is again, it's being taken up on a large scale. Uh, the requirement would be almost 27 to 35 gigawatt. So total energy ecosystem would be greater than 60 gigawatt. The investment opportunity here would be like close to 50 billion US dollars. Now, why does this storage matters? This is mainly because of the renewable integration, peak demand management, grid stability and resource adequacy, and the energy security. Now, how do we build a flexible renewable energy grid? So, the following initiatives have been taken by the Government of India, Ministry of Power. You might be aware of earlier the renewable energy purchase obligation RPO was there. Now the government has initiated energy storage obligations. That is, out of your total power demand consumption, there would be a percentage of energy that you have to commit on the energy storage. So this is called as energy storage obligation. Then there is a viability gap funding, and then there is a public linked scheme. That is, earlier it was like achievement linked scheme, and renewable plus storage competitive bidding. Uh, these opportunities would be like for the battery manufacturers and BESS development. So as of now, most of these lithium ion or the rare earth metals, whichever is being there or being imported from our neighboring China and the eastern countries. So this will be a good opportunity for the manufacturing sector. And in case of Tamil Nadu perspective, this can be implemented wherever this high renewable energy penetration is there. So we have a need for battery energy storage and the pumped storage mechanism. And the next topic of highly discussed is like the support for green hydrogen and industrial growth. So the green hydrogen corridor is likely to come up in the in the district of Tuticorin, where we have access to the port. So this energy storage would be the bridge between renewable energy growth and the grid reliability. So now, how would Tamil Nadu and the nation across can implement this grid farming things? So first and foremost would be like pilot projects, grid code requirements, battery energy storage tenders with grid farming mechanism. And the fourth would be like ancillary service market and real-time monitoring, mandatory grid farming in weak grid zones. So only when we were able to come across all these things, we would be able to implement this grid farming technologies. Now, the last aspect would be on the firm FDRE, that is firm and dispatchable renewable energy. So what is this firm and dispatchable renewable energy? So the Government of India issued guidelines in June 2023 for procurement of FDRE power through competitive bidding. So here the objective is to provide reliable renewable power, peak power support, round the clock clean energy mechanism, and reduced fossil fuel dependence. So now, before introducing this FDRE, you would have all known the term called round the clock supply of power. So in the round the clock supply of power, since it is the renewable energy resources are diurnal and intermittent, the term of RTC was replaced by firm and dispatchable renewable energy. So this firm power, it will guarantee availability on a contract. So whenever there is an availability of both wind and solar, it would get contributed, and the balance power would be mostly from the battery energy storage systems. So it can again be a dispatchable power. The power can be supplied during specific hours, especially when during the peak demand periods, and then load following capability. So the generation follows the DISCOM demands profile rather than simply injecting the energy whenever it is available, which means the renewable energy generators must follow the DISCOM's demand profile whenever, based on the demands projection, the power has to be injected by the generators where they have come into agreement on the FDRE rather than merely generating whenever they can generate. And then the other features would be like reduced grid balancing requirement, which helps mitigate renewable energy intermittency. And also there would be a reduced dependence on thermal plants for balancing. So at present, this is being discussed, like how this firm dispatchable renewable energy can be merged with open access. So this has been termed as firm dispatchable renewable energy, and open access is the emerging opportunity for open access consumer. So what is meant by open access? So open access here, and any HT consumer who has a contract demand of 100 kVA, who is connected in the HT lines like 11, 22, and 33 kVA and above, he can procure power from any of the renewable energy generators. So they will enter into an agreement where they will enter into an energy wheeling agreement. So based on the grid conditions, the injection voltage and the drawal voltage will be taken into apart, and based on the monthly billing cycle, the energy that is generated and injected would get adjusted. So this is called as the open access agreement. So how this fast the firm dispatch renewable energy would mean for any open access consumers. So the potential uses like data centers. Now the topic of data centers is being taken, and they have a huge market and power consuming center. Some data centers require huge power of almost like 100 megawatt to 250 megawatt that is in the pipeline. So all these data centers, they would have an condition on consuming only green energy power. So second would be semiconductor and manufacturing sectors. Third would be green hydrogen, which is said to take place, and then the automotive industries, and then CBAM, that is on carbon trading mechanism. So as you are aware, recently India and European Union has entered into a zero trade agreement scheme where mostly would compile under the CBAM. So what are these are really meant for the consumers? So the consumers, they increasingly require renewable energy that should be reliable. It should be on predictable cost. So this firm and dispatchable renewable energy, it can provide all the three. That is renewable energy, reliability, and predictable cost. So now what are the challenges that is being faced by the FDRE? So you know the cost of storage is very high when compared to establishing an renewable energy power plant, either solar. So it's still the largest component in the firm and dispatchable renewable energy. Forecasting accuracy, it requires really high quality wind forecast, solar forecast, and load forecast. And recently, we are also facing the effects of El Nino, where at present across the nation, uh, the forecasting is it's getting struggling because of the El Nino effects on the wind forecasting. And then the transmission congestion, especially during very high wind seasons. And then the demand side management exposure, where poor scheduling can lead to deviations and penalties. So these are the challenges ahead on implementing firm and dispatchable renewable energy. So this would be the end of my presentation. And now it is open to the forum for discussion.
Uh, uh, there would be, if there is any questions, we can have more interactions because this is a very new subject, and most of the professors as well as the asking rate of this particular technology itself need to be leveraged as a workshop. But we expect more questions. Let us wait for the questions, please.
Sir, I am Ilango. I am asking a small question, sir. Doubt. Actually, you are telling about the batteries and storages and other things.
Okay.
But at present, there are so many battery charges will be there. Whether anybody is, that is any other than a lithium battery, any material they stored at least 12 hours supply, sir, for normal residence building.
Okay. See,
Other than lithium battery. Other than lithium battery.
So, no, this sulfur-based batteries are being tested, and then if you could see um, the flywheel technology is also being tested, and one more thing is these are all because of the cost. See, if you why these are not going on a more success rate is like if you compare the cost of electricity compared to an European nation, where the cost of supply of power that is supplied to domestic consumer is highest in the European context. Second highest would be commercial, and the least would be for industries. Whereas if you take developing countries like India, we are providing subsidized power to
No,
the domestic
very
category.
public. Yeah.
Yes. So that is why we face a more implementation challenges in this. So if you take a normal inverter, either it is like a 750 VA or up to 1,000 or a 1 kVA inverter at home with the normal cells, its lifeline would be like 4 to 5 years, but the cost is like almost it comes to like 22,000, which is very high. When I'm getting a very subsidized power, why should I go for this?
That is the
So
reason.
this is the general public opinion of the developing nation.
Sir, in India, whether what is the contribution in geothermal energy, sir? Because nowadays everybody they are talking about tidal power plant, and then there is wind energy, and then solar.
See, we have ample potential in onshore. Okay, rather than to go for offshore. See, whatever technology we have in the Eastern or the European nations cannot be practically applied to the Indian context. See, if you see the European grid, let me finish, Professor. In the European context, if you go for offshore wind, their seas are not rough and there are no storms like how we have in the Indian oceans. You will get a firm power like almost for 10 to 11 months. If you have an offshore wind farm either in the Mediterranean or across the coast of Gibraltar or across the North Seas, you get firm power. Like a wind farm will be like 600 to 600 megawatt or 1000 megawatt or close to even 2000 megawatt that has already been established in 2007. So our the context and the local conditions are entirely different. See, we need a buyer and a user. So hence those technologies are it will take a lot of time to catch up here. But battery systems, would really catch up a lot here in the coming years.
Okay. But why I'm asking this question is we have more than 7,000 kilometer coastal area.
Understood.
So that's what why we are not able to concentrate much in geothermal and other aspects. That's what I'm asking.
Okay, sir. Okay, okay.
Okay.
Because we have huge land here, and the huge potential for solar and wind is there onshore. So the
Mhm.
cost would be like would be very high to tap those geothermal resources.
Okay. Thank you, sir. Thank you.
Thank you, Professor. Thank you.
Sir, good evening, sir.
Yes. Good evening, ma'am. Yes.
Sir, I'm Dr. Malati from EEE Department, SRM Engineering College, sir.
Okay, madam.
You have said that grid forming inverters. I said a lot about the grid forming inverters, and these
Okay.
grid forming inverters are used in isolated areas, no, sir. Remote areas. Remote areas. This is applied for remote areas.
No, ma'am. No, ma'am. You cannot say it has to be applied only for remote areas. See,
Can be.
see,
It
see.
can be.
No, it is not entirely for isolated areas. See, if you can see, it would differ like case to case. Like I had mentioned, no, like where are all the possible potentials? If it
Yes,
is
sir.
even if it is even for a um, single substation where even a 1 megawatt of power is also there, we can also go there. But mostly, we do not know how the grid parameters changes instantly on either the fault right through or what to say a sudden dip.
Okay, sir.
So your question is like whether you have come across or you have gone through some journal papers.
No, sir. In the slide I have presented, you have indicated that it can be used for islanded things that are remote places.
Yes,
Hence,
ma'am. See, why it has mentioned that it can be used for islanding scheme is when there is a grid disturbance or when there is a blackout. No, we can
yes.
instantly start. Yes, we can instantly start from the battery energy storage systems where we have this grid forming technology, and from that we can synchronize with the solar plant. Suppose it's 12 noon or 3 noon. Suppose if there is a blackout, I have
Okay.
a remote system for islanding system somewhere down in Ramnad or Sivangai district.
Okay.
So I can start the grid. The black start can be done from there with the help of battery energy storage systems where there is a grid forming inverter. I can able to make the battery energy pump into the grid, and from that I can synchronize the isolated systems. I can initially islanded. I can make it synchronize with the local solar power plant, and then I can inject into the grid, and I can enable subsequent uh, synchronization with the whatever available mechanisms that I can immediately bring back into the grid.
Okay, sir. So in that case, is how the active power and reactive power being shared among the grids, sir?
Initially no, so that is a black start. So
Okay.
initially I will not be loading too much. So gradually I will be loading, and roughly it would be like 1/3. See, in grid forming inverters, the challenge is like I will be forced to reduce my active power to support reactive power mechanisms. So these
Yes,
markets
sir.
are evolving. So there has been only very few tests that has been conducted by Power Grid in association with Indian Institute of Science, Bangalore. Um, so in my research, I am actually trying to get these through one of the 5 megawatt battery storage that has been recently commissioned in Tamil Nadu. So it is also on a pilot basis. So honestly speaking, I don't have the actual data on um, the injection of reactive power from this grid forming inverters.
Okay, sir. Thank you, sir.
Okay, ma'am. Okay.
Thank you. Thank you so much, sir.
Okay, ma'am.
Bala, if there is no other questions, meant I think you can give vote of thanks.
Yes, sir. So, if there is no questions, we can go for vote of thanks. So, I think any questions there? Any one last question?
Sir, I had a question.
Okay.
Grid forming inverters, could they be used in behind the meter applications where or in scenarios where we want to be independent of the grid?
Okay. Actually, I was expecting this question. See, what is the need to go behind the meters? Uh, so this has been practically in my experience. That actually there is no real reason to go behind the meters because the technology uh, is only to make the grid as a resilient grid where it would supply the necessary voltage and to reduce the rate of change of frequency. So I don't think it should be for behind the meter alone.
Okay, sir. Thank you.
Okay, welcome. See the grid farming. See, it's mostly this topic is very new in the Indian context. So there is very little research, but much of this research is almost going on like almost like 3 to 4 years in the European context, and Chinese are more doing a lot. Um, See, this grid farming is unlike the conventional. We say it as grid following, where all your solar inverters are the wind. It will only follow the a grid. Okay, so here is the grid forming inverters by their technical capabilities. It will form a grid. So what are the present issues we are facing? So the main issues we'll be facing in the intermittent grid is the voltage fluctuation. So if you take on a real cases, my 11 kV grid would have a low voltage as low as like 8.7 kV. So what would really happen is when we go for these technological changes, your 1 megawatt solar plant, if you go it on a per unit basis, you will be there will by changing this firmware concept, there will be a reduced active power. So in order, I can enforce this mechanism. So it should be looked on a large scale. Uh, it's a very large grid. So we have more challenges in implementing this. So first and foremost is like we need a strong grid codes. Again, uh, the Central Electricity Authority, it is coming up with few changes on this. So only when it is strictly being enforced, there would be a grid discipline across the nation. So it would take a minimum amount of time um, for this to catch up in the industry, practicing engineers and who are all there as a system operators. And only then it can really be implemented. So otherwise, the storage and other solutions like uh, thinking from the Indian context of view, everywhere they say that it's all too costly, and now we need not go for it. And I was using the term ancillary markets. So only when ancillary services like how we have the spinning reserves, it's getting developed. So this will really come up. See, it's now the time is like 7:10. Solar power is no more. The wind will start slowly. So if there is even a rate of change of frequency of 0.01, when the ancillary services are there, so the grid planners from the load dispatch centers, they know that yes, at this time I have like 1,000 megawatt hour of battery energy storage that has been saved from the excess power that has been generated from the solar plant. So I can inject across all these buckets for the next 1 year, 30 minutes, 15 minutes cycle interval for at least like a block of like 15 minutes block for the next 4 to 6 blocks, so that I can have a quality power supplied during the evening peak periods across the various important junctions, like where all I have my weak nodes.
Yes, and Nalasimhan sir, there is one another question in the chat box, so it's a
Okay,
fantastic question.
what is that question? Yes, let me go through.
Yes, they have asked. So one Dr. S. Padmanabhan Ayyappan has asked, what is the role of AI in managing renewable rich power systems? So
Okay,
many would be having the same questions. Okay, please go.
see, what would be the role of we need to train. See, most of us think that, like, I do agree that most of the AI resources can be used in the power system, but we need to train the system. Like, even I have used, no, like in the ancillary service markets, I need to train up my network. Like, if this condition A gets simulated now, see, if there is a heavy rain now in Chennai, whether it is in the evening 5 o'clock, my solar power, I would have minimum solar, but entirely it would go off. So to take the system response and to have a resilient grid, I must train my network. Yes, if this situation A occurs, I have to bring up my battery storage or my grid farming technology at this node. Either it is at Sri Perumbudur substation or at the Chennai Anna Salai substation, or any the Quartu substation or Avadi or Kottayambakam. So I have to train up my network. But to train up my network, I must have a very high skilled resources who is operating the system. But definitely AI do have a role in this.
Yes, good then. So if no questions is there, someone was about to ask questions. So if it is going to be the last question, we can go ahead, sir. So anyone willing to ask that question? Some interruptions was there. You can have an interactions. Please, audience, you can put up your questions frankly. You can query directly to the sir. Okay, so thank you so much. It was an eye opener. Really, it's an eye opener, sir. So I just need to think about something else because the industry asking rate is very high. That the where the colleges and other things, other institutions need to develop such phenomenal changes because the papers and other things are coming. But real asking rate of this industry, whether this energy power crisis would be the major problem for the next future. So we could see that lot of things happening around us, like Strait of Hormuz has made a possibility that we need to go ahead and have energy through only electrical energy. So the grids and other things are, it's going to be a older technology because the firm power, it's going to be an inform power. Inform power is going to be a firm power as per your directive. So in such case, the technologies need to be an updated one where each one need to understand about such things. So in case we might have an opportunity to have a workshop or 2 days conference on such parameter, it would be a helpful thought process for all the engineers, I think so, because hope everyone would be agreeing, because I could see more than 40 people connected in the initial period and they are still connected means I could see that it has brought a change. So it's a thought process by Nalasimhan sir. So he is about to become a doctorate as completing this project. So I wish all the best for his own career development as well. But this is a thought process where people need to understand about it. Thank you so much for the organizing team. So I also need to thank the joint secretary, so who is none other than Dr. Sri Raja Balaguru, so who is also closely working with this wind energy and other things. So now we also, but in your contest, you have given CBAM as well as OA. OA itself need to have a very good thing, that is we need to have a separate classes for it, because many such industries where the HT industries, they want to go with net neutrality. So that questions also need to be answered. We would have, as we are running out of time, so we might have it at a later time. So thankful for your presence, sharing your thought process. Because I could see that you are still in the office communicating such things. So it's the dedication after office hours, whether we would have the energy to deliver, but you had a wonderful smiling face, keeping up all the data, and you are delivering a very good lecture. So that is we are thankful to you. The institution of engineers, the people
might be knowing that why we need to be a practicing engineer. So now this session has brought about the change that every professors who are connected here, so they need to bring about their students to connect with us, and there is a channel which is to be put up. So we have a channel. Please subscribe and make a like to that, so that whatever invitations that is being put up, you can just connect, and it is all done for our engineers. So it is our courtesy to give the such information. Means we are here to connect with you, to have the 15 disciplines with all the programs scheduled, and it has been programmed. So we also about to come up with our website. So please follow it. Thank you so much, our chairman, who has given an elaborate opening on such areas, and he has triggered the questions. So like offshore and onshore, so like that sort of questions, and the battery energy storage. And I also see that the madam from SRM, so like the people have connected with a larger sector, so they have come up with all along from different areas, and I could see all the participants who have been very actively participated. I could also see Karpsami sir, so from BHL, so he has given a thankful note. So I also need to thank all the council as well as committee members who have joined here. So thankful to all the members who have joined today, and we would be coming up with more sessions in the forthcoming days. Thank you so much for your time. Thank you. Thank you, Radhi ma'am, so for organizing such an event. Thank you, ma'am. So we can close with this event. And whether there is a common question, whether the PPTs can be shared to the common public, Naleswan sir, if it is possible, you can share it so that I can put up it in the chat itself. So that would be the happiest moment for the people to continue to hold with questions. And we are closing up the session. Thank you.
Thank you so
Thank
much
you,
for the
sir. Thank you.
opportunity. The PPT will be shared. Thank you.